affected by magnetic forces.
Now, electricity is the general term for the interaction of electric charges. Electric force is the attractive or repulsive force between charged objects.
Okay, so we will be talking about the interaction between electricity and magnetism. Our complex question is, how do the characteristics of an electromagnet affect its power?
Now, some of the characteristics that we came up with were the nail size, nail material, length of the wire, battery size, and how much the wire is coiled around the nail.
So here we have D batteries, C batteries,
AA,
and AAA batteries to use. We also have a paper clip that we can try to pick up.
We have different types of nails. Aluminum.
This is a nail made of aluminum.
This is a nail made of iron.
And we have two different wires that we can coil around.
This one is very long.
And this one is shorter, and you can coil it around much easier than that one.
Okay, so we're going to start out with our first question. How does the size of the battery affect the power of the electromagnet?
And we are claiming that the larger the battery size, the more powerful the electromagnet is. So we're going to go to the utmost extremes. We're going to test the electromagnet with two D batteries, and we're going to test an electromagnet with two AAA batteries.
So we are going to start out by using the D batteries. We are going to connect the north pole of this battery to the south pole of this battery.
Okay.
And we are putting them together with tape. Now, we are going to take the wire. We are going to connect.
I'm going to connect one end to the north end of the battery and one to the south end.
And we can tell that there is electricity running through because
it gets extremely hot.
It starts to hurt.
Yeah. Okay.
Now,
we'll have to flip it around.
We have the nail.
Is it on there? There we go.
We have this nail that is coiled with wire. Is it hot?
Yes.
And we are going to try and pick up the paper clip. Now it's picking it up. There is a magnetic force running between the nail and the batteries, and it's holding it up. So this is our evidence for the D batteries. So
now we're going to test the AA batteries.
Do double.
Or the AAA batteries, sorry.
So now we have two AAA batteries, and I'm going to tape them together. North pole to south pole.
Get that out of there. Okay.
All right, they are connected. We're going to take the same wire.
And tape them to each end, north and the south. Sorry, this side's hard to do. All right.
And it's on.
Yep. Now we're going to test and see if it picks up the paper clip. And it does.
Up. And it's holding it just like the D batteries were.
So, in conclusion, we have a final claim that the size of the batteries do not have an effect on the power of an electromagnet, because as you can see, when we used two D batteries and two AAA batteries, they had the equal amount of attraction to the paperclip. All right. Our second question is If the material of the nail is not a good conductor, there will be less or no attraction. So here we're going to test an aluminum nail, and we're going to test an iron nail, because iron is a better conductor of electricity than aluminum. We're going to use the 2D batteries that we already have taped together to create the electromagnet. And we're going to test
the
aluminum nail first. Going to tape one end to the positive side and one end to the negative. And there is electricity happening here because it is getting very hot. Now we are going to try and pick up the paper clip. And as you can see, it is not working. So far,
there's no magnetic field.
There's no magnetic field being created through the aluminum because it is a poor conductor. Now let's test the iron nail. We're using the same copper coil, so that way we're not changing any of the variables. Tape one to the north end, one to the south.
And it's hot.
And it's hot again. All right. And as you can see, it's picking up the paperclip once again. So, after creating two electromagnets, one with an aluminum nail and one with an iron nail, it has supported our claim that the different materials of the nail can affect the power of an electromagnet. Aluminum is a poor conductor of electricity, therefore it did not create a magnetic field strong enough to pick up the paperclip, whereas the iron nail is a very great conductor of electricity and created a magnetic field in order to pick up the paperclip.
Now we have our third question. We are asking, how does the amount of times the wire is coiled around the nail affect the power of the electromagnet? We're going to use an iron nail.
We are going to claim that the more times the wire is coiled around, the more powerful the attraction will be of the electromagnet.
So this nail is completely covered with coils. We are going to connect it north and south.
It is coiled around exactly 12 times.
Hot. Oh.
You okay?
Yeah.
Okay.
The whole thing is hot.
Yes.
Doesn't feel very good.
No. All right.
Careful on doing this at home, children.
And now we're going to test and
it picks up the nail. Or it picks up the paperclip.
okay.
So
there's a good magnetic field, a very strong magnetic field. Now we are going to only wrap it around 4 times. This is just access wire right here. 1, 2, 3, 4 times around the nail. And we're going to test it again and see if this has any effect on it.
it's hot again. Okay. And it still picks it up exactly how it did when it was coiled around 12 times. So it looks like 12 versus 4, it does not matter how many times the wire is wrapped around the nail.
Therefore, our final claim is the amount of times the wire is wrapped around the nail has no effect on the power of the electromagnet. So, here we have 3 different possible inquiries. And finally, an electromagnet is created by the electrical current flowing through the wire, creating a magnetic field around the iron nail, which allows them to pick up the paperclip. And this supports the idea that electricity and magnetism are intimately related. So, once again, I'm Rachel.
I'm Chelsea.
And that's the end.
Thank you very much.
Bye!